Hi, my name is Nicola and I'm a cloud technology consultant at Oracle. Today, I'm going to talk about the Oracle Big Data Cloud Service, which can be used to capture and analyze the massive volumes of data generated by social media feeds, email, weblogs, photographs, smart meters, sensors, and similar devices. It's no secret that big data represents a huge opportunity for companies, and with Oracle Big Data Cloud Service, all the relevant data can be leveraged to speed time to business value. The problem that most of us face today is that our data warehousing environments have not been built to give us the insights that we need. And here's why. Let's look at an example. Imagine that you are the owner of a small coffee shop. Earlier in the day, you had the customers coming in, purchasing a cup of coffee, and then leaving. So you essentially have all the purchase transaction, and that the transactional data lives in your environment. In addition, you may have data about your inventory. So how many coffee cups do I have? Do I have enough coffee beans? Basically, all of that inventory data. And so what you decide to do is merge the information by taking your inventory data and your customer transactional data about what coffee they're buying and at what frequency. And so what you decide to do is merge the information by taking your inventory data and customer transactional data about what coffee they're buying and at what frequency. This way, you can make sure you have enough coffee for your customer, so the next time the customer walks in, they always get what they need at the right time and at the right place. And that was it. So, some data records from those different sets of data is all you needed to give that great customer experience. But we don't live in that world anymore. Let's say I was a brand new customer going to this coffee shop. So the first thing I do is go to your website to see store locations and to find out if there's a coffee shop walking distance from me. Next, I may look on social media sites and forums like Yelp to read reviews about this coffee shop and learn if it's a good place to go. Finally, I actually walk into your coffee shop and purchase that cup of coffee. And if I had a pleasant experience, I may tweet about it. And a couple of days later, I may go on my mobile phone and purchase some coffee beans directly from their website. All of these are examples of the new world that we live in. I, as a customer, have interacted with this company in so many ways. I've introduced clickstream data by going on your website, social media data by tweeting, mobile data from my phone, and so many other data sources. Not only is the number of data sources increasing, but the amount of data coming in is increasing. To top it off, we have structured data coming in. We also have fragments and snippets of data coming in, like semi-structured sensor data and unstructured streaming video data. And guess what? 85% of a company's data is unstructured or semi-structured. So here's the question. Do you want to grow with your data or be suffocated by it? Hopefully, you want to grow with it. So that requires us to analyze our data warehousing environment and figure out if what we need now is a data lake. A data lake is basically the idea of you plunking in all this data coming from various sources, structured and semi-structured, in this lake. Then later on, you can look back at the data and decide what data from this lake that you want to use for additional processing, analyzing. You don't need to worry about ingesting all this data which goes into the data lake. To achieve this, there is an open source data lake technology called Hadoop. The reason why big data is a challenge is because implementing Hadoop and Spark infrastructure is really hard. According to Gartner, 60% big data projects fail. And why? Because 49% of people struggle with figuring out Hadoop. I think this is best expressed by Terry McFadden, Associate Director, Global Business Services, Procter & Gamble. I was convinced that Hadoop was the answer to our big data challenge. We did not want to knit our own cluster. Oracle Big Data Appliance gave us the shorter path to value. We could drop the implementation in and start chopping on problems. In a matter of days, we were loading data and beginning to work on it, McFadden said. Let's have a look at the industry trends in data platforms. The world has been powered by relational databases for 30 years. All this is table stakes. It has been the engine of enterprise data management and e-commerce, but in an era of big data is no longer enough. Many new multi-structured datasets have emerged that do not fit the traditional SQL paradigm well. System logs, click streams, sensors, and machine-generated data. This drove the development of NoSQL systems and Hadoop as a way to store and process these datasets in data lakes. But the cloud enables a new approach to building a better data lake. It's based on open source technologies in the same way that Hadoop is, but it addresses the main issues that depress customer satisfaction and success with Hadoop: lack of elasticity and the complexity of operating a successful Hadoop cluster. So, at a high level, here's what you need to know about the Oracle Big Data Cloud Service. It's purpose-built for big data workloads. It is a generic infrastructure. We offer both dedicated infrastructure as well as elastic options. Mix and match as your needs dictate. The entire power of the Oracle Cloud is now at your disposal. All sorts of great tools, workflows, and an amazing set of rich data sources, ready to use to enrich your own. Oracle does most of the heavy lifting on infrastructure, patches, support, and maintenance. You bring your own tools and still have direct access to the environment. Pricing is clear and transparent. Pay for what you use. And of course, it seamlessly works with the on-premises big data appliance. So let's see together with a demo how to create a big data instance in Oracle Cloud. After registering and activating your free Oracle Cloud trial account on cloud.oracle.com, we can browse to the Oracle Cloud Infrastructure console. If your account was recently created, then this is the current home page of your cloud account. The list of available services can be displayed by using the top left navigation menu button. As it is possible to see, big data is currently not present. This is because, at the time of creating this video, Oracle Cloud is still migrating all the existing accounts from the previous existing homepage to the new one. Here is how to access it. So from the services list, scroll down to the bottom, and within the administration option, click on My Services dashboard. This is just a temporary step while all the account migration completes. Using the top left navigation menu button, in this case as well, all the services will be shown, including the Big Data Compute Edition. Let's then click on Big Data Service to load the related page. There are some prerequisites to create a big data instance: an object storage bucket, an OpenSSL utility to generate API signing keys. Note, in Big Data Cloud, the PAM key must be created without a password. And few details from the cloud account, such as a user or CID, the storage bucket URL, and others. Please find in the description below this video few links to the cloud documentation containing the prerequisites how-to steps. Let's now click on Create Instance. Type the instance name, a description, check the drop-down menus of region in case multiple options are available, as well as availability domain and subnet, where it's possible to select the Manage Compartment for Pass from the default No Preference setting. Then click on Next. Check the default cluster configuration settings and change the details as and if required. The question marks next to the field will show a brief pop-up window with an explanation and further details. The availability of some of the features of the big data instance change depending on the cluster settings. See the Create a Cluster link in the description. For example, Oracle R Advanced Analytics for Hadoop, ARA, is installed for Spark 1.6 clusters only. And we can see here that there is as well version 2.1 available. Another example, if fewer than 3 nodes are specified, then the instance won't use the high availability mode. In the credentials section, the default username can be used, then type in a password that match the required complexity rules. For the SSH public key, used for authentication when using an SSH client like PuTTY, To connect a node associated with your cluster, click on Edit, then select Create a new key, and then click on Enter to generate it. Make sure to download the zip file with the key pair now, as once this pop-up is closed, it cannot be retrieved again. Moving on to the cloud storage credentials, we'll pass in the details previously prepared. OCI Cloud Storage URL, which is the Oracle Cloud Account Infrastructure Object Storage URL. OCI Cloud Storage Bucket URL, which is the URL of the object storage bucket previously prepared for this instance. OCI Cloud Storage User OCID. OCID stands for Oracle Cloud Identifier, and it is an Oracle signed unique ID. In this case, the ID related to the user profile in use to create this instance needs to be added here. This can be retrieved from the Cloud Account User List or within the relevant user details page. OCI Cloud Storage PEM key. This is the key previously generated using the OpenSSL tool. Click on Browse to select the .pem file. OCI Cloud Storage PEM key fingerprint. This fingerprint of the .pem file, which could be either generated via command line or more easily retrieved from the user details page by opening the API key section, as the fingerprint is automatically generated once the public key is loaded there. Finally, check that the block storage settings are matching the business needs. Last but not least, there is as well the association section, in case additional provisioned services in the cloud account needs to be associated with this cluster. For example, this is helpful if you have an Apache Spark jobs that require interaction between services or have some dependencies. Click on Next to load the confirmation page showing a quick recap of the settings selected for this instance. Click Create to create the instance, which will be usually available in around 2 hours. An email will be sent from the system as well to advise when the instance is ready to be used. Once the instance is ready, it is possible to see the cluster details and access the Big Data Cloud console. The Apache Ambari console and others too, such as Big Data Manager, to access and manage our Big Data Cloud clusters. While Ambari isn't needed for normal operations with the cluster, it's useful to open Ambari access to help with troubleshooting and certain administrative actions. Let's now see the customer success story of Halliburton, one of the world's largest oil field service companies, catering to the energy industry with big data. Halliburton improved operational efficiency in delivering hydrocarbons using Oracle Big Data Cloud Service. Halliburton made the move to Oracle due to the cost and complexity of another public cloud provider. Watch the following video to hear Shane Miller, Senior Director of Global Infrastructure and Operations at Halliburton, talk about how Oracle Cloud has allowed them to improve their operation efficiencies for hydraulic fracturing while providing them 50% in cost saving for big data analytics.
Halliburton is a global oilfield services company. We're just over 50,000 employees in 80 countries around the world. About 10 months ago, we made the move to the big data platform from Oracle. Before we moved to the Oracle Big Data Analytics platform, we were using another cloud provider just as IaaS, which meant we had to manage all the underlying componentry to keep that environment up. After we moved to the Oracle Big Data platform, all of that management went away. We get to focus on our analytics. Big data analytics has had a big impact at Halliburton, specifically the product line that does hydraulic fracturing. What we've been able to discover using analytics has made significant improvement in operational efficiencies in how we deliver hydrocarbons out of the well. That's a big deal because it allowed us to cut in half our cloud spend on big data analytics. When we look at Oracle and our future, it's really all about cloud. Today we're big data platform customers, and we are accomplishing the goals that we meant to accomplish with the big data platform. In the very near future, we will be taking advantage of things like Cloud at Customer to run these databases.
As you have seen, it is relatively quick to get a big data instance started. So give it a try today, and thank you for watching this video.